Yeah, that's perfect. Okay, start. So, good morning, team, and happy to stay with you and discuss a little bit on the things that are ongoing between Europe and the US. Can you briefly introduce yourself and say what is your job and why you are dealing with artificial intelligence?
Yeah, first of all, Alberto, thanks for spending the time and being part of the pediatric moonshot. Just a quick story. I have no background in healthcare. I've had a long career in software. I actually was the first president of Oracle's cloud computing business. I retired from there, actually went back to Stanford and started a cloud computing class there. And that's where I met Dr. Anthony Chang, who introduced me to your world. And I learned things like, oh, people are still using CD-ROMs, pass data around. And as we all know, to make advances in AI, you have to have access to large quantities of diverse data. And so I'm thinking about this going, boy, these are all the same problem. And so we put a team together several years ago of a bunch of infrastructure engineers, people I've worked with in the past, and we set ourselves a mission. Our mission was to create privacy-preserving, real-time applications based on access to data in all 1 million healthcare machines in all 500 children's hospitals in the world. And that is what we call the pediatric moonshot.
Okay, so how many hospitals are involved so far in the pediatric moonshot? We are with you, and we are struggling to move on very fast. Although we have a lot of challenges coming from technical infrastructure, but also regulations that are different between the US and Europe. How many hospitals are on board so far?
So there are varying levels of involvement at this stage. So that we have established what we call edge zones in 8 hospitals on 3 continents already. And then there are probably between 8 and 16 other hospitals who are engaged either in the development of AI applications or in contemplating the delivery of such applications in the pediatric community.
Good. So very exciting. So can you briefly tell why federated learning is interesting for healthcare and for data sharing when you, we try to develop some AI applications?
Yes, I think it's actually a very important point. Classic artificial intelligence, meaning everything from ImageNet, which was, a contest that was established at Stanford maybe 10, 15 years ago now, all the way to ChatGPT, are based in an idea of centralizing data. So you centralize the data in one location, you create training data sets, test data sets, et cetera. And that's how these applications are developed, is really all around a centralized model. And I don't think that's going to work for medicine for a variety of reasons. So let's just do a simple exercise. There are 500 children's hospitals in the world. The Echo Labs, just the Echo Labs, actually create 6 million terabytes of data per year. Now, if you contemplate that amount of data, we actually have the ability to build highly accurate algorithms given that amount of data. Okay, sounds good. Okay, let's go centralized. Where are we going to put it? Okay, let's put it in Ireland, right? Okay, first of all, well, who's going to pay the data transfer cost from Rome to Ireland, from San Francisco to Ireland, from Ireland back to Rome? Second of all, and this is experience we've had in enterprise software, is when you aggregate data, what you end up doing is building a schema for that data.
Correct.
It's inevitable. And it works for the first application, but the second one, it's really difficult. The third reason is you're never going to build real-time applications in Ireland. The fourth is, we very early on, we engineered around security and privacy. We knew this was job one. In fact, one of our core team members has 14 years of privacy law experience. One of the fundamentals of privacy is purpose limitation.
Mhm.
When you go put a bunch of data in one location, you can't explain the purpose of it. That's not privacy, right?
Mhm.
And then finally, and I think in Europe, you're more aware of this than we are in the US, the whole issue of data residency and data sovereignty. I know in Norway, they're saying, medical images are never leaving Norway, right?
Right.
Okay. So what that argues for, and that's what we have built, is a highly decentralized approach to doing this. So we, meaning Bevel Cloud, has engineered a highly decentralized, in the building cloud service. Now, why does it have to be in the building? Well, the only way to get to the, and I'll talk ultrasound for a second, to get to the ultrasound data is you must be in the building with the ultrasound. So we, and your teams help with this, have engineered a highly secure mechanism by which these edge servers can live on the network with the 1 million healthcare machines.
Yeah.
Right? Okay. So that's great. Now I can build applications that I can do collaboration. If I build an AI application, the inferencing engine can now run on the edge, meaning in the hospital, in the clinic, and frankly, at some point in the home, right? Okay.
Yeah,
That's
you're right.
all easy. The hard question is, how do I train? How do I learn on this 6 million terabytes in distributed, right? Okay. Thank goodness our friends over on the consumer side have been working on this problem.
Mhm.
So for all of the people listening who have iPhones, Siri is trying to get more accurate in listening to your voice. Well, it could take Alberto's voice, Tim's voice, and send it to the Apple Cloud. Well, what about privacy, right? And, it chews up a bunch of network bandwidth as well. Okay, so they developed a technology referred to as federated learning. And the whole idea is I'm going to learn locally, meaning I'm going to learn on your phone. And the only thing I'm going to transmit is neural network weights, which are just a bunch of floating point numbers.
Exactly.
So, right? So it's far less data. And obviously you can't figure out from neural network weights what anybody said. So we've done preliminary experiments that say we can bring this technology to the world of healthcare, particularly the world of imaging. And I would argue it's the only way we're going to build AI algorithms, AI applications in medicine is through federated learning.
Amazing. Thank you so much, Tim. And thank you for your time. And I'm looking forward to meeting you in person as soon as possible. Thank you.
See you soon, Alberto.
See you soon. Okay. So this is the interview. We're done. In the meanwhile, we are working